Okay, so I'm gonna move on. The last feature of the bullets themselves that we haven't added yet are in the original project when you shot the cubes, they would turn into this colorful material that was built into the engine. Let's see. So if I shoot, this isn't even the right character. Let's see. I'll open up this other project. When you shoot a bullet and it hits the cube, the cubes are supposed to turn into this colorful material, and you can still pick the cubes up. It's just that they're a different material. And this is, in the class example, this was a good example of how to use event hit in Blueprint. So in Blueprint, I think it was in the bullet itself, things that have physics are supposed to have this callback function called event hit, which returns information such as what you hit, where you hit it, and things like that. And so we need to handle the events in which the bullet and the cube collide, which should call event hit for both of them if this option is enabled on the static mesh. Not simulate physics, but generates hit events. So if this is checked for one of the objects that are in the collision, this object will receive an event hit once it actually hits something else. So here is my other example project. So it's supposed to do that. So let's implement this. Get this out of the way. Put this headset down. Here we're going to see. So last time we, let's see, where is this? Last time we created callback functions for actual actions to handle overlap, or to handle the event hit, which is a callback in Blueprint that just exists, that was made for us. To actually create this event, we need to do basically the same thing that we did with these actions, where we create a callback that receives that overlap. And we have something that is not bind action, but does kind of the same thing. It creates callbacks for these built-in physics functions and other callbacks that are built into the engine called add dynamic. So, and this is not an input, so we don't actually, it's not an input, so we don't put it in set player input component, we do it in the constructor. So the bullet itself, so in C++, we'll need to do the equivalent of checking the generate hit events, this thing, and we'll also need to set up this event hit function. So let us do this inside of the bullet. So event hit, remember that all these physics callbacks are based on the meshes themselves. The this what's called a sphere here, which was actually called bullet mesh here. So we're going to need to add the callback to bullet mesh. So bullet mesh, let's see if Visual Studio actually cooperates today. It does. So bullet mesh has a definition of the function for event hit, but you need to bind it to your version of a function that actually exists in the class. It seems like there should be a way to do it the way that Unity does it, where you just kind of overwrite on component hit, but it's not that simple in Unreal, unfortunately. So this is on component hit is the definition of a function. What the hell? We need to use this function called add dynamic, which is not auto-correcting right now. Thank you for nothing, Visual Studio. Add dynamic. And it needs a couple of things. It needs the actual object, which will just be this, like last time. And it needs the name of the function. This time, Visual Studio's information here is actually kind of useful for once. So the object will be this, because we're adding the function to ourselves. And we need to give it a function to bind to, so we'll just create a local version of event hit, which we can do in the header. So events hits. Before I start with this, the way that callbacks work, the user input was a really simple case with bind access, because each of these access callbacks only return a float that tells you how much of the access is being, like how much is the joystick being pressed, or something like that. For these physics functions, it's a little bit more complicated because they have more parameters, and we need to receive most of them. The C++ definition of this function is a little bit different, but we still need to basically have all of these parameters in a certain order. You can find these what are called signatures on component hits. You can find these signatures online, and it will tell you what parameters you should need. Well, I thought it would. I know that they exist somewhere. Otherwise, you can just look it up, I suppose. But somewhere you'll find a reference for what the signature should be. I already know what it is, so I'm not going to bother looking it up. But you can always look it up if you need to and look up for examples. But your signature, the signature of the function that you create locally needs to be the same as what it expects for on component hit. So the signature that it wants specifically is this. So I'm just copying this from my other project. I called my local function event hit, and it wants the other components that you hit, the other actor that you hit, or sorry, this first one is the component on yourself that was hit, which in our case will just be the bullet mesh. The other actor that was hit, the components on the other actor that was hit, the impulse, and the hit itself. So it's a little bit different from the blueprint. The reason, if you're wondering why, if I'm just adding this callback to bullet mesh, do I need to have a components parameter saying which of my own components was hit? Because it would seem like I'm adding. It would seem like this function only works. Like you might be thinking that this function is only supposed to work on this component anyway, so why do I need to receive it? It's because you can bind event hit to any number of meshes that you add to your actor. For the bullet, you only have one mesh, so you only have to worry about bullet mesh, but for other more complex actors, you may want all of them to call the same event hit, especially if you have a lot of meshes, like if you have a human that's split up or something like that. And that is basically how the blueprint event hit works anyway. The blueprint event hit is basically binding this function to all of your other static meshes. So if I add more static meshes, all of these, if they have this enabled, will receive this event hit, unless you define otherwise. Like you can define a specific component was hit in Blueprint, which you can also do in C++. But for now, we're just going to use the general purpose event hit. Moving on. we have this signature of our local function. Then we can throw our local function in here to work with in the body. And then we can bind we can bind ourselves to this function, or bind on component hit to this function, which we do by saying @a bullet. And add a bullet is basically grabbing the class definition event hit. So this is my hit. And so now I said that when the bullet mesh gets hit, when the bullet mesh gets hit, it should call this function of mine. And it will. So now, if you recall the blueprint definition, I grabbed the other object, I tried to cast it to what was a pickup cube before in this project, and then I tried to set material on that. I actually do want to turn these cubes into specific classes so that I don't turn everything colorful. And I can do that by making another C++ class. I will make this... These can just be static mesh actors because they don't do anything except receive hits. So I can do show all classes, static mesh actor. I'm going to call it... This was BP pickup cube, but in this original project, I think all the BP pickup cubes were a subclass of collectible, which had nothing but a treasure value. I'll do the same thing, even though in this tutorial I don't actually have a need for the treasure value. But I'll add it anyway, just to keep the code consistent. So we'll add these classes, and then we need to add the... I'll actually ignore treasure value, but we still need to initialize the mesh. We need to add the mesh component in the constructor, define what mesh it should use, and define its material, and some of its physics parameters, because otherwise C++ won't do any of that for you. It's taking longer than it should. I mean, oh, okay, well, I was just about to give up. So here's our static mesh actor. Static mesh actor doesn't have the... Static mesh actors don't usually do anything, so I guess they don't bother to autofill any of those functions, but we can add them ourselves. It's just a collectible. This is our constructor. And then we can add the definition in here. I already have the definition. I already have the auto loading of all of these things in a different project, and last time we already saw how to do this, so I'm just going to copy it. So what it's doing is it's loading the cube. Oh, I forgot to include these things. Collectible. I need to include all of these things. So what it's doing first is it's loading the regular cube, the one that it's using now, this 1M cube. It's telling my own static mesh component to use this as its mesh, and this .getStaticMeshComponent is a function that already exists for static mesh actors, because a static mesh actor is just an actor that has a static mesh. So this is how you get its component easily. Then I'm forcing them to be a certain scale. In this case, I made all of them 0.2, so I'm going to keep using that value because this is pretty good. I make it use the cube material, which was... I guess the cubes... I have been using a different one because I copied this, but the cube materials are normally gray, and they're here. They're part of the starter content. I'm telling it to simulate physics so that they fall. which is also the case here. I'm making it movable because if you simulate physics but you have it as static, they won't do anything and it'll keep throwing error messages. So you want to force it to be movable. And let's ignore... I'm going to remove these for now because we don't have a use for them immediately. And I don't want it to be confusing yet. So, basic cube setup. I'll compile this and replace all of these cubes with my new C++ cubes. And recall that if you have classes that have visuals, if it compiled correctly, you should see the mesh change here, but instead Unreal just crashed on me. So that's great. Blueprint's really good at eating errors, I'll give it that. C++ does not eat errors, it just crashes when something goes wrong. It's really annoying. Anyway, it compiled correctly, you see the cube here now. An easy way to replace these cubes here with my collectibles is select them and right-click them, and there's an option for replacing them with this. So you can see it auto-loaded the cube material and it set their scales. It also set physics to be enabled, and I think that's all I asked it to do, and it made them movable. And you can tell this is the default because it doesn't have the yellow arrow there. So here are my C++ cubes, which I can now use to try to force cast the thing that the bullet hits to one of these to make sure that the thing that I shot actually is one of these, which is also what I did in the blueprint. Like this, except I'm doing it with collectibles now. Back to the bullet. When the bullet hits something, it will call event hit. For now, I don't have a text mesh attached to the bullet, so what I can do instead to print out hits is glog.log, which is an easy way of logging things in C++. Bullet hit something. Oops. Just to show you that the event hit is actually working, which is hopefully the case. Is bound. I don't know what all that red is because it did compile successfully. Let's see if it complains here. I think it's just unhappy because I'm trying to do this while the cubes are still alive or something weird like that. Set material is not a member of useStaticMesh. I don't believe them. Collectible.h. Get static mesh components. Alright, well, this compiled last time I did this, but whatever, it's unhappy this time. That seems to be all that I complained about this time. Oh, compiled locally. This is it's yet another example of the Visual Studio compilation, the Visual Studio compilation not being synchronized correctly with the editor compilation. I don't know what happens, but it is always annoying. If I compile, I don't know. I'll play it and see if it does anything. This is my cone. Here's my gun. Okay, let's swap controllers randomly. Pew, 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 pew. My bullets are moving way too fast. Set mass override the bullets. I may be adding too much juice to the bullets. Although that shouldn't affect whether or not it receives hit events. The cube is not receiving hit events. I think I believe if the collectibles are not they don't generate overlap events and they don't generate hit events, they might not generate any events on the other actor, the bullet. So for the collectible for the collectible I may actually need to force them to generate overlap events. Otherwise I might just not do anything at all. The bullet itself seems to be configured correctly, I think. The bullet is not generating hit events. I may not have yet forced it to do so. Ah, yes. I need this. Whoops. You need to do this to force it to generate hit events. And this is definitely not worded the same way as the blueprint checkbox is, but it is the same thing. A lot of these name changes between C++ and Blueprint are caused by some residual naming conventions from the days of Unreal 3. Okay, so the bullet, I'm feeling, yep, there it goes. I don't think I trust the binaries anymore, to be correct. If you're worried about these crashes or weird errors, sometimes it helps to flush out the cache of the project. So in this case, close Visual Studio and delete binaries, intermediate, and the solution. Then right-click the view project, generate Visual Studio project files, and sometimes this helps just forcefully clear it when things are acting up. Warning, that's fine. I'm gonna right click, build. I would cut out this whole part of me struggling to get Visual Studio to work correctly, but I think it's fun. Maybe some people would be enlightened by some step of this troubleshooting process. It's always fun to see just how much CPU everything is using. And every single time I do this, I find that Epic Games Launcher is using a ton of CPU for no reason. It's not doing anything. It usually throws that error with missing modules when you delete binaries. The binaries not being clean is a problem. See, here's the thing, it's not actually... Building it in Visual Studio should have stopped it from doing this. So I don't know if there's just bad cache happening right now or what. But, yeah, this is irritating. What was I going to say? Oh yeah, the binaries being unclean is a problem because if there is a binary here, when you try to open up the Unreal project, it tries to load one of these binaries before deciding to recompile everything. And if the binary is not clean, that means it's loading an old version of it, which can be a problem. Alright, so my bullet should now be... It's generating overlaps and hit events, which should be fine. The cubes are generating overlap events. Let's hope that means that when I try to shoot them, it's rolled over my cereal box. Pew, pew, pew. Let's hope that shooting them now throws this output. And it didn't. I don't know if something is horribly wrong or what's happening here. Ah, I remember. Event hit needs to be declared as a U function. Otherwise it gets unhappy. Even if you don't intend to use this for Blueprint, Unreal really does not like it when you're trying to force bind their built-in functions to functions of your own that you haven't specifically said are going to be used with their built-in functions. I guess it's like Unreal's way of trying to force consistency between your code and theirs. Yay, it's stopped complaining. Did we get our message though? Yay, we did. Bullet hit something. It generated a ton of these, even though I only shot a few bullets, because right now in my code I'm not actually, I'm not discriminating between different types of things that I hit. I just generate this event whenever the bullet hits anything, including the ground. So when it's rolling around on the ground, that is still causing these events to happen. I'm gonna add a little bit more juice to the bullet, but not too much. So now that we handled that, well, yeah, now that we handled that and you know what causes that error, we need to test the other actor to make sure that it is in fact another one of these collectibles. And we do that, well, I'm going to do it the naive way first. We want, first of all, I need to import a collectible. Collectible.h. Hopefully I spelled it correctly. What is Visual Studio doing? It keeps opening the wrong version of this file. Oh my god, that is so irritating. Okay, now it seems okay. Every time I was clicking one of these, it would... See, why does it have multiple header files for bullet? Visual Studio is a piece of trash. Anyway, I have included a collectible. So now I'm going to try to force cast the other actor into a collectible. And again, it's a pointer because most things that you deal with in C++, in Unreal C++, are going to be pointers because it likes to handle all of this stuff internally. And it's a memory management thing. So you may be tempted to do it Java style, where you cast it like this. But this is going to cause a problem in C++ and C. What the hell? Include collectible. This should be fine. I'm ignoring Visual Studio. Visual Studio is horribly messed up right now. I mean, as far as I know, I don't need to import anything else. It's just Visual Studio being very, very dumb. Because I know that collectible.h is here. I'm going to set this as startup project, which sometimes helps with these things, but I really do think it's just Visual Studio being dumb. So I'm going to try to cast it Java style, because people may be tempted to do it that way. But we'll see in a second that this won't work, because that's not how C++ and C work. So I want to test if this is in fact a casted hit. Actually, we'll get into this later. For this part, I just want to do finishing up this bullet interaction with event hit and teleporting. Casting it this way may not cause a crash. Actually, okay, well, we can force it to cause a crash, just for the sake of going through this example, by implementing our treasure value. So if I throw in this treasure value, and let's say that for whatever reason, let's say that it's like a shoot 'em up and I get points for shooting something, and so locally I store the value. So value equals casted hits treasure value. I spelled it right, I didn't make it public though. Public. This I think will cause a crash because of the way that I'm casting it, but we'll see. Otherwise we'll see this cast not work later. I think not making it public explicitly was why I was complaining before. By default it's probably protected or something. Yeah. Treasure value. Oh my god, Visual Studio. Whatever. Moving on. If there is in fact something that we hit that is of this type, we want to change its material, casted hits. We need to know what material to set it to. But let me finish this first. Remember, set material, its index that we're setting is the first one because this is a cube that only has one material. And then we want to set it to be something called colorful material, which I haven't defined yet, but we'll define it now. From the class example, if you recall, I was using this thing called bone weight material, which is just an engine material that's colorful like this. I was just using it because it looked cool, and I'm going to keep using it. So we want to change this into a colorful material, which I need to grab the way that we've been grabbing materials thus far. So I'm going to copy this from my other code. I didn't need to make this a U property, I just did as force of habit. but I declared this uMaterial called object material, other object material, before it was called other object material. I'll change it to colorful material. Then we need to find it and set it in the constructor. Oh, the reason why I made this public in my example that I'm copying from, it is my example, it's a different project that I have already completed. The reason that I made this public was just so that we can see in the editor that I did in fact assign it. Anyway, in the constructor we're going to find and assign this material. So it happens to be at this location. So I am loading it from this location. You can right click something and copy reference to find that location. I'm loading it to something called loaded material, and then I want to say colorful material equals loaded material dot object. No thanks to Visual Studio's autocomplete. And now I'm setting it to be this. So this should work. Well, it will load the material correctly. I still think it will crash when I actually hit the object, but we'll see soon enough. Otherwise we'll see a crash by the way that we're casting it later. Alright, I compiled. The bullets did in fact load this material, and here it is. So let's play this and see if it crashes. I hope it does. Otherwise it'll crash later. What the heck? Oh, it's because the bullet, these bullets are rolling around. It didn't crash though, which means that I guess casting it this way in this particular circumstance is okay. We won't be so lucky later. But there is a better way to cast it that you're supposed to use in C++. Anyway, you can see it. Well, actually, it didn't crash, but it's also not doing what we wanted it to do. We wanted it to only turn those specific cubes colorful. But you can see it's turning everything colorful. And that is the unintended consequence of the way that we're casting it. So the way that this Java style cast works in C and C++ is, as far as C and C++ are concerned, these things are just pointers. They're just hex values that it's converting into other hex values. It doesn't actually care if you're casting this pointer into this type. It's just casting one hex value into another. Actually, it's the exact same hex value technically. It's just stored as a local value. So when you cast it this way, C and C++ don't care whether or not this thing is actually of this type, and it will forcibly cast it, and you know, casted hit may not actually be of type collectible. You may have just forced another actor to be of type collectible. And why it wouldn't have crashed when I'm doing this treasure value is baffling me. Maybe it is actually eating an error somewhere. I didn't think C++ ate any of the errors, but maybe it is this time. Anyway, the point is that this is not how you're supposed to cast things in C++. C++ has a better way of casting things. That is this. You're supposed to use something called dynamic cast, which does, like in C# or Java, when you cast something this way and then check if other actor or if casted hit is null, which is what we're doing here, to check if something is of this type, you need to do that in C++ this way. You need to say dynamic cast to this type. You're casting this object into this type, and dynamic cast is specifically for trying to get this. You're trying to get this thing to be this, and if other actor is not actually a collectible, then the result will be null. So this cast is more stable in C++. And so what this should do is only color the cubes. See? So now the cast is actually stable, and it's not forcibly casting these other actors into a collectible, because dynamic cast is a bit smarter, and it does actually turn the casted hit value variable into null if it's not actually a collectible. So anyway, that was the most long-winded explanation of the simplest thing, but hopefully if you run into that problem in the future, you know that this is the way that you cast it. Anyway, there we go. There are our colored cubes. So we're done with the bullet mechanics. Let me do navigation quickly and then end this part of our tutorials. So the way that navigation worked, by the way, the cone is way in front of the character right now because I didn't save game mode last time, so it's still using the BP pawn, in which I made the cone forward like this. I'm actually fine with still using the BP pawn, but I do want its cone to not be that way. So for teleportation, what we want to do is when we hit a button, we point our cone in a certain direction. Oh my god, there are too many things open. And also the frame rate has gone horribly wrong for some reason. I closed some other project. What we want to do is point our cone that's in the non-gun hand in a direction and get our character to move to that location, which was simple enough in blueprints. If in the blueprint version of this project, that was done here in the go to there function, and we raycasted to wherever the user was pointing, and this was the final result using a Navmesh. But first let's do the naive way of doing it without the Navmesh. So let me get rid of the bullet and collectible if this is confusing. And there are two CPPs open. Okay, so first let me define the inputs that we need. Last time I called the input go to there. Oh, also, let me demonstrate, because remember that last time we set up the first person character input. Let me demonstrate that shooting the gun still works. Where are the bullets? They're not coming out of the right place, but it's there. Oh, it's because the camera, for some reason. The camera, the first person camera is facing the wrong direction. You can fix that if you decide to use first person character. Just rotate the camera 180 degrees in the constructor or something. Or it's probably because the motion controllers are initialized backwards or something like that. But the shooting does work in first person, you just have to rotate things. Moving on, we need to add the input for go to there. It was the Vive right trigger last time, and as before, we need to... Why did it open another header file? Visual Studio is really getting on my nerves today. As before, we need to make a function for go to there when the user presses the button. And I'm going to make a function called go to there. Put it in my header file. And because I'm lazy, I'm going to copy this from 4. I have go to there, and for now, just to start off, I'm going to throw this function here, and I have the text set. So naively, what we want to do is raycast in a direction and set our character to be the location that we hit. And this is going to be a problem because if you recall, this doesn't handle the fact that the character should always be on the ground or have gravity, but we don't want to have gravity on a VR character because it'll be sickening. Anyway, raycasts are really easy in Blueprint. They're not so easy in C++. In C++, the raycast method actually works very similarly to how you do it in Unity. So in Unreal, we make a result. We make some object that will receive the information from the hit. And there are two ways of doing this. And one way is basically the same way as Unity does it, which is what we'll do for now, just to kind of get the point across. The other way is the way that Unreal does it. So the way that's closer to Unity is, remember that Unity can't draw lines in game when it does raycasts. So what you need to do at first is draw the line yourself and then do the raycast. We'll draw the line if you do actually want to see it or if you want to see it in scene mode but not game mode, because it will never show up in game mode. You need to draw the line yourself. In Unreal, you can still draw lines that way, except it will also appear in the game. So just like Unity, you have draw debug line, and we want to draw debug line has a couple of parameters. Its first parameter is the game world that you're trying to draw this line in. Second parameter is where it will start. So it will start at the right mesh get component location. Remember that get component location is the same as get world location in Blueprint for a component. And the end points will be right controller's location, get components location, plus the direction that you want to shoot it times the length that you want to shoot it. So remember that the cone's up vector is actually the direction that we want to point and shoot. So right mesh, get up vector, and I'll just shoot some really far distance. Next parameter is what color you want. There are some predefined colors inside of the fColor static class. I'm going to use green for now. Then you have, is it persistent? I'm going to say true because I want, otherwise they'll be so, I don't know, I just want them to live forever. So they'll live for 100 seconds, but I also said they're persistent, so they'll just stay there anyway. Depth priority I'll leave as 0 because it doesn't matter. Thickness I'll leave as 1 centimeter, which may be too thick. And for now, I'm not going to worry about the raycast. I'll just show you that it is in fact shooting in that direction. So this function is similar to the draw debug line in Unity, except in Unreal you can actually see the line in game, but in Unity you can't. Compile. This is my gun. This is my cone. Oh, I may not have bound it yet. Or I bound it to the wrong thing. I did bind it to the wrong thing. Left trigger. Yeah, I want a right trigger, sorry. Right trigger. Anyway, you can see it shoots in that direction. And in Unreal you can draw the lines in game, in Unity you can't. So this draw debug line is still useful for some things, but I actually like the remember that in Blueprint you have the visualization of when you shoot at something, you get a little square where it hit. Ideally we want that visualization, but first I'll show you how to do it this way. The naive way of doing this is to use a function called line, or a function of getWorld. So if getWorlds naively you would use this line trace single by object type, which will draw. It'll do ray tracing, but it'll stop when it hits something, as opposed to line trace multi, which will return all of the objects that it hit. The first parameter is where you're going to be returning the hit. The second parameter, the other parameters are basically the same as these, like the start and end of this vector. The next parameter is and it's hard to tell because Visual Studio has been absolutely worthless today, but the next parameter are the types of objects that you want to hit, and you need to give it this object query params. It seems a little bit intimidating at first, but fortunately they have some built-in ones that are easy enough to use. So f collision objects query params, and we want to create one of these, but there are some initializations that are easy to use. F collision objects query params init, what the freaking hell, init type oh my god, so not only is Visual Studio being absolutely worthless right now, but it's also overriding things that I'm writing. Init type all objects. Okay, I just want to hit anything. And I need one more parentheses. If I hit something, so if there is in fact an actor that I hit, then I want to print on my output text the name of that actor. For now. We won't worry about the actual movement of ourselves yet. And here is actually where we'll see that the casting will cause a crash if you do it wrong. Okay, wait, this. So this whole part isn't an if statement because it will return true if it hits something. If you naively assume that it hits something that is an actual actor without doing any kinds of casts or checking, it will just crash, because as we'll see in a second, it's possible to hit things that are not actors. And you may be wondering, like, what in a 3D scene can be an actor, or what can be in the 3D scene that is not an actor, and that thing. I actually don't have any of these in here. Did I delete them? That's fine, I'll just copy it. That thing that can be in the scene that is not an actor is a brush. So if you shoot and hit a brush, it will crash. And the reason that that's worth mentioning is because in the standard VR scene, these things actually are all brushes. So we'll see this crash. So it's fine when I'm hitting these things, and it's fine when I'm hitting nothing, but when I hit a brush, it will crash. See? Because a brush is like, this weird specific object that exists in Unreal that is not an actor but actually can appear in a scene. So that's why you want to make sure that this, if you're going to actually use the actor, which we're not, we only care about the position that it hits, but if you are going to use the actor that it hits, you want to make sure that it's an actor. So this if statement would make sure that this crash doesn't happen because it's an Navmesh. Or not a Navmesh, sorry, a brush. While this is loading, now that we know that this is hitting things and we know how to prevent it from crashing if you try to get the actor without it having an actor, we can position ourselves at the place that it hit. So naively, let's say that we do this set actor location to be where it hit. So this hit object will have all the information that we need to do this. It has impact point, which is where the raycast hit. And right now with we're using the worst method of raycasting, so we don't get a visualization for where it hit, but we'll fix that in a second. Okay, so naively, I'm just going to position myself anywhere that I hit. And this is a problem because I don't have gravity, so I can kind of launch myself up here and get stuck in walls, which is a problem. And you can see that it's kind of just breaking everything. And we also have this kind of bad raycasting visualization. So first what I'm going to do is just switch to what I consider the better raycast visualization, which is the same as the blueprint one. So the blueprint raycast, this line trace, is not actually this function. It's using something from our good old Kismet library that I mentioned last time, because Kismet was the OG blueprint in Unreal 3. So the better raycast is from Kismet. Let me make sure I imported it. I imported Kismet math library, but I need Kismet system library, which has the raycast that I want. So the better raycast is, let me get rid of this. The better raycast is Kismet, or, oh my god, will Visual Studio ever work for me? Use Kismet system library. Let me compile it and see if that fixes this autocomplete. Otherwise I'll just deal without it. Also with this raycast, we don't need to draw a debug line anymore. I can get rid of this. Kismet, there it goes. Kismet system library. It has line trace single, which is what Blueprint is actually using. And its parameters are the world, so get world, start and end. The start and end are the same as before. The other parameters are a little bit more confusing, so hopefully this video helps not make it so confusing. Then it wants the trace channel. Trace channels are kind of annoying to convert in C++. For now, let's say that we just want to trace and hit things that are visible. Or let's do static. Yeah, let's do static, I guess. The way that you convert from these trace channels, like what I was using in Blueprint, the way that I convert from these to the C++ version is by doing this. Engine types convert to trace type, and then it has a couple of trace types. So you can see it has these that you can define, then it has your physics bodies and your world static and things like that. I'm going to use world static because that's what we used in Blueprint. Then it has some other parameters. Trace complex was false. Why did the autocomplete stop working? The other parameter is important. False. Then it wants the actors to ignore. So you need to make that array. What I did was, just like in Blueprint, I tell it to ignore myself. So I'm going to create this array and add myself to it. So T-array is Unreal's built-in array that it wants you to use. It's basically it's a wrapper for standard vector, which is like C++'s version of an array list. But it's a wrapper that Unreal likes to use because it has some optimizations, I believe, for this specific type of array, and it also has some functions that work better with Unreal as well. So anyway, we're going to pass in this. Then it wants your debug type, or what type of drawing you want to do. If you use this enum, you can see what options you have. So draw debug trace. Why does it do that? I'm going to use persistent like last time. Your out hit is still hit. And finally, ignore self is true, which means that I actually didn't need to add myself to the array, but I did anyway. The other ones are optional, like what colors you want to use. I'm not going to worry about that. Anyway, this is basically, it's still doing the same as the previous ray trace that we were using. It still returns true when it hits something, and it still returns all that information into the hit result. It's just that this one will give us the nice visualization that Blueprint gives us, where you hit something and it shows you a little square that says where you hit it. Maybe I'll do navigation as a separate video, because this one is longer than I expected it to be. Thanks to Visual Studio, the most useless IDE that exists. That's not true. There are much worse ones, like MonoDevelop. God. Anyway. Pew pew. Oh, this is. Oh, it's working. Yeah. See, these are the rays that we got in Blueprint, and these are also the rays that we get in C++. And it doesn't return anything when it doesn't hit anything. And we still have this problem. And also remember that it traces green for the rest of the ray trace. So I had it trace 100 meters, I think. So it traces green for the rest of the 100 meters after it hits something. It doesn't return any green squares or red squares if it doesn't hit anything. And we still have this problem where I can break it and go out of bounds and get stuck on walls and things like that. So we'll solve that. Let me solve it now, because I guess it makes sense to put all of the teleport material in the same video. What we need to do is, like in Blueprint, we want to use the navigation mesh to give us that information. Now, the VR scene, this VR scene actually came with a navigation mesh already. The first-person character scene didn't, so we can just add one. Let me see if I forgot anything. Crash. I had another step on my list of things to do, but I don't think it's necessary. The like the other naive solution that we tried last time was to keep the x and y of the impact point but not the z, so that our character would stay at the same height but would translate along the ground plane. If you remember from the blueprint lectures, this sort of solved the problem with getting stuck on walls, but we still had the problem where we can get way too close to walls. So anyway, yeah, what was I saying? We should add a Navmesh. You can do this by doing navigation mesh volume, navigation mesh bounds volume, and just expand this along the ground. You don't want to make it too big because then it will encompass things that you definitely should not be able to get on top of, like the top of here. I want the user to stay on the ground plane. This is still too high up. Yeah, so I want them to stay here. This looks fine. If you, by the way, you can show this visualization by hitting P. P will disable and enable the Navmesh. You can do build paths to build the navigation mesh, which will return this thing called Raycast Navmesh default, which is what we want to reference in C++, so that we can use it the way that we did in Blueprint, where we can use this function called project point navigation to figure out what is the nearest safe area for the character to be able to raycast to. So we'll do this, and I'll show you a problem when we do this. So if you, C++ still has Raycast Navmesh, so if you do UE4 C++, Raycast Navmesh, you'll see that it does have this, but watch what kind of problem that we have when we just import the include here and nothing else. You would think that this would be enough to give you all the information that you need for navigation, but it will not. So I have imported this, and now I need to make a reference to it so that we can create a variable for it. So make a U property for this. So we have a Raycast Navmesh, and I have my U property, which lets me assign it in the editor. And that's all we need to do for now. If you're wondering how do you grab this thing without assigning it in the editor, so actually I think I did that. Let me see my example code quickly. Oh, never mind. This is something that I plan on touching on anyway. Okay, so we're not going to assign the Navmesh in the editor. What we're going to do is get it, because there's only one of them in the scene. So you would think that it's easy enough to just grab it, and it is. Similar to GameObject.find in Unity. So I want to initialize this Raycast Navmesh, and what I can do is grab it. So the Navmesh equals U gameplay statistics. I don't know if I need to import this. U gameplay statics. I do. This is another Kismet library called U gameplay statics, which has one of my favorite functions, which is get all actors of class, or get actor of class, which will only get one. U gameplay statics. It would be nice if Visual Studio would ever autocomplete anything correctly. It has this function called get actor of class. Its first parameter is the world that you're trying to get from, and we are trying to get the first thing that is of type Raycast Navmesh. Static class, because we're getting a class, not a pointer. It will complain about, oh look, it auto-completed, what a coincidence. Navmesh is undefined. Did I name it something different? No, it's just Visual Studio being dumb as usual. Let's compile it. It will complain because I'm not actually casting it. GetActor of class, I believe, just returns a type of actor, so I need to do my dynamic cast to get this to be a Navmesh. Dynamic cast, a recast Navmesh. Cannot include that is what it's named, I think. Well, there's a reason that this error is showing up. Although I thought it would show up slightly later in this tutorial, but it's fine. The reason it's throwing this is because there's another step to force it to grab all the Navmesh files. Let me finish this. So I will need to cast this to recast Navmesh. I'm writing so slowly now. My frustration with Visual Studio is making my brain hurt. There's another step that we need to do to get it to find all these files, because the navigation library is an example of a module, so you need to import the entire module to be able to grab any of these header files. So you may have noticed that when you see all this information, you also have a module that it wants you to include. And there are a lot of things that are embedded in modules, including third-party libraries. To include this module, you do it in this file, build.cs. And you'll notice that it already included some modules, like the core library, the engine, and also head-mounted display, the basic VR library. We are going to add this module that it says that we should add, navigation system, so that I can find all these headers that I want to include. So there we go. Visual Studio is really not working today. I mean, it was throwing an error for the most basic thing, adding a string to an array. Adding this module should help it find recast Navmesh. See, it's blue now. For once, Visual Studio actually had a timely update. So now it included the right thing. It knows where this Navmesh library is, because it's in the navigation system, and all is good in the world. I casted things correctly. And this will give me my Navmesh. And Navmesh is a public variable, which means that, it's a blueprintable value, which means that if I play this and click my player, I should see that the Navmesh is there. VRBP pawn. VRBP pawn. VRBP pawn may just not be showing things that are inherited. VRCPP pawn. Oh, classic case of the editor not being updated with Visual Studio. I think. It says hot reload here. Well, no, it says starting hot reload. It didn't actually hot reload the Visual Studio module, which is always fun. Alright, VRBP pawn, there it is. So grab this recast Navmesh, and now it's here. Now we need to do something with the Navmesh. We need to use it to find a good place to actually teleport to, instead of just naively throwing the character at the point, or using the X and Y of the point. So we can do that by using the same function that we used in Blueprint, project points to navigation, and it's still pretty much the same function. So we didn't really take advantage of this in the Blueprint, but this function does have a return value like the Raycast, which means that you should wrap it in an if statement to make sure that it actually found a point to navigate to. So we are going to do this. If Navmesh project points, and if Visual Studio were useful for anything, you would have seen. Oh my god, this is so irritating. Any day now. It has a couple of parameters. The first parameter is it's the same as the blueprint basically. So the first parameter is the point. So we're going to use the impact point as the initial guess. The second parameter is kind of like with the Raycast. It saves the information to another object. In this case, it saves it to something called an fnav location, which is the location that it found. So we're going to use that. Hey, look, it auto-completed for once. So you see the fnavmesh or fnav location, whatever. Then we are going to give it some bounds extents. In the blueprint lecture, I used 1,000, 1,000, 1,000. And that's all we need for now. And so if it does find this point, we're going to set actor location to be the point that it found. That is better than just the wall itself. So outNav dots location. That is the point that the Navmesh found as being a more ideal place to teleport to. And because the Navmesh is on the ground here, that also, like, this just automatically deals with the problem of height. So it will only project a point. Actually, maybe it's easier to see in this visualization. Draw poly edges. It will only project a point onto this actual mesh. So since this mesh is on the ground, that means that it will only place your character on the ground. It will only use this actual mesh. So let's try it, and then I'll end here. Pew, pew, pew. If I try to go up the wall, it won't let me, and I'm a suitable distance from the wall because the Navmesh is telling me that I can't go that close. And yeah, this is a lot better than climbing the wall, although it still will be buggy if I try to navigate. If I do something like this, you need better. So right now I'm at the edge of my tracking area, which means that the center of my tracking area is kind of like over here, I think, but I'm sitting at the very corner. And when I do set actor location, it's moving the tracking center, not my head. So if you want it to be smarter about this, you should, when you do the set actor location, you should offset it by however far I am from the center to make sure that if I'm near the edge of my tracking space, that it doesn't teleport me into something else, even if I'm not in the center of my tracking space. So anyway, this is a lot better, and today was a struggle with Visual Studio. You see I can still kind of break it because my navigation mesh is not strict enough. You can make it a little bit stricter. I'm actually not sure why it would have. I think it's just that my tracking space is so weird right now, but you can make it a little bit stricter by making your agents wider. So I made my agent radius a lot wider. Oh god, I'm very unhappy with that. Oh great, it didn't even save it. Unreal is acting like Unity today. Navmesh bounds volume. I want to extend that far. I'm going to save it this time. In the project settings, you can change things like the Navmesh navigation. You could change like this default size of an agent, the agent's radius. I'm going to make them bigger, like 100. Actually, 60 was what I was using before, and that seemed pretty good, so I'll use this. And then rebuild. I see that it's ignoring me. Agent radius 65. If I try to shoot, my cast may not be good enough. Or not my cast, this check that it hit something may not be good enough. Or it broke even harder and it's not finding the recast Navmesh, which is also possible. So recast Navmesh 65. When I play it, interesting, it just kind of deleted it. Very interesting. Just straight up deleted it. Force rebuild on load. Dynamic. I don't understand why it keeps deleting it. It didn't delete it this time. But it's also not the size that I wanted it to be. Agent radius. Maybe if I restart it. All I need to do is post some rants for why I hate Visual Studio next. I don't know why it's ignoring my agent radius. I don't remember what else I need to configure to get this to work correctly. Collision generates. Yeah, it's weird. It just deletes the Navmesh. I don't remember what else I need to configure to get this to work correctly. Force rebuild on load, dynamic, can be main, can be spawn on rebuild. Oh. Auto destroy when no navigation. Maybe that's what was deleting it. No, it's just deleting itself. I don't know, I give up for now. I don't know what causes it to do that. Normally it does that when, at least in my experience, it does that when it's not, when the navigation mesh is not set up the same way as the one in the project settings, but this time it's just kind of, I mean, this time it's definitely supposed to be okay. It definitely looks okay to me. Force rebuild on load. Agent radius 40. Did rebuild it. Raycast Navmesh 1. I'm kind of curious, just bear with me, if I do this and then try to move around. Oh wait, I don't have a non-VR version of this. Go to there, let's make this right click, right mouse button. So if I play this, I get this recast Navmesh that it rebuilt for no reason. It should. I just wanted to do this. It's not crashing, it's just, well, yeah, I mean, there's so few navigable areas that it's doing this, but I don't know, it is acting weird. The nav meshes are a pain to work with. Oh well, that's it for now. You can figure out the navigation stuff yourself, because that's not related to the C++ part. Bye.